Alright, I'm gonna go over the correction of quiz 7, the version 1, the version that we did not finish. You started it and I stopped it in class. Some of you have started understanding this pretty well, but others still have some difficulty with it, okay? Okay, let's go, let's start. Okay, well, what's the first question? You have to evaluate an integral. This is a definite integral. Okay, it's not an indefinite integral. Okay, what does it mean that it's a definite integral? Do I have something thinner here? It means that is it thinner? Yeah, it means that you have 4 ways to do that. Okay, 4 different ways to evaluate a definite integral here. Let me go right here and let's go over the various way. So if you're given a definite integrals, what can you use to evaluate it? Okay, so 4 ways. First one is going to be directly. Okay, second one, third and fourth. Directly, what does it mean? It means you know an antiderivative of the function f. Directly means you're gonna do sum from a to b of f of t dt is f of t, capital F, not this one, between a and b. What's capital F? Where f of t is just an antiderivative of f of t dt. Okay, this is not a definite integral. This is an indefinite integral, right? And it's the same as an antiderivative. Okay, so this is a direct approach. I see f of t and I can get an antiderivative. For example, you know, I mean, this is simple, right? If f of t is t squared, then antiderivative of t would be 1/3 t cubed. This is a fundamental theorem of calculus, of course, fundamental theorem of calculus. All right. Second way is not too far from that, but it's indirectly. Meaning what? Meaning I'm looking at this integral here that I have to compute, and I don't see an obvious antiderivative of f of t. But if I do a u substitution, then I will find an antiderivative, okay? And I will rewrite the integral as sum from, I don't know, it's not going to be a to b, this time it's going to be c to d, for example, of g of u du. And after rewriting the whole thing like that, this time I will be able to take an antiderivative of g, capital G, between c and d, and I got it. Okay, all right, so these two methods are very similar to each other. The second one, of course, because it's indirect, is slightly longer. Third approach is geometrically. What does it mean? It means the definite integral is an algebraic area. What does algebraic means? Algebraic means it can be a positive or a negative area. If I just say area, it's area means always positive normally, right? Algebraic area. So in this case, well, you know what it means. The area of what, right? Suppose A is right here and B is right there. You're gonna count the area negative when it's below the x-axis, and you're gonna count it positive when it's above the x-axis. Okay, so this will be counted positive and this one will be counted negative. But of course, for that to work, you better have some nice shape, nice geometrical shape, geometric shape. What does it mean, nice? Well, that you can get a formula for. Okay, so it means you're dealing with a rectangle, you're dealing with a triangle, you're dealing with a circle, or half circle rather, stuff like that, okay? Alright, and finally, last way is you do a numerical integration. There are many reasons for that. I'm not going to remind you the reason here, okay? There are two main reasons for that. Numerical integration, that means you can do a left rem, formula for that, right rem, formula for that, tem, formula for that, okay? And we have seen the formula in class. The main difference between all these different ways is that the first three ways, so here already like that, in blue, right here, these three approaches here would yield an exact value while the last one, as its name indicates, would yield an approximated value, okay? Very, very different. Alright, so let's go back to our problem. This is a little reminder. Okay, so what do we do now? What do we do here? Okay, so we're gonna do a U substitution. U substitution. Why? It didn't say so, right? But when I look at my my function inside, I don't know of an obvious antiderivative of that, okay? Of an obvious one. It's not too difficult, but I don't know of an obvious one. So, how am I going to do my U substitution? Well, let's set U equals x squared plus 1. Let's get du. Du is 2x dx. Which is good, because if I solve for x dx, I will find 1/2 of du. Why did I solve for x dx? Because I see this piece right here, x dx, right in my integral, and it's right there. So that's good. That's good. That's going to be easy. Almost there, except that I have a definite integral, therefore I have to take care of my boundary. If x is -2, okay, these values are taken by the variable of integration, that's x. If x is -2, then u is -2 squared plus 1, right? It's right here, my substitution. So it is 5. And if x is 1, then u is 1 squared plus 1 is 2. Okay, and be careful, you're going to have to rewrite them in order, okay? The 5 correspond to the -2 and the 2 correspond to the 1. And it doesn't matter if you get the smallest one, the largest, below the smallest, alright? You got to be careful with that. Okay, how about we rewrite the integral, okay? So sum from -2 to 1 of x divided by square root of x squared plus 1 dx, this integral is equal to the integral from, so -2 corresponds to 5, 1 corresponds to 2, x dx, right? X dx at the top, that's 1/2 of du, I'll rewrite it after, over square root of x squared plus 1, that's square root of u, okay? So let's rewrite it like that. Integral from 5 to 2. I'm going to put 1 over 2 root u du. Now, by this time, you should know an antiderivative of this function directly. Okay, it's not difficult. That's because we've seen it plenty of time before. You should know that this is the antiderivative of square root of u. If you divide square root of u, you'll find 1 over 2 root u, okay, between 5 and 2, and so the answer is root 2 minus root 5, okay? Very nice, very simple. All right. Now, some of you do not know that this is the antiderivative of this, okay, that this root 2u is the antiderivative of 1 over 2 root u. And that's okay, just take your time and compute it. But the problem is that some of you are making mistake while computing it. Now that's not okay. There's only one formula for it, okay, let me write it here. Sum 1, and I'm not antiderivative, okay, 1 over 2 root u, this is an indefinite integral du. You only have one formula for that. I'm going to take the 1/2 out, and I'm going to write u to the negative 1/2 du, okay, and let's apply the formula. That's 1/2 times, okay, 1 over 1 plus negative 1/2 times u negative 1/2 plus 1 plus c, okay. The formula is, the only formula is this one. Sum of xn dx is 1 over n plus 1 xn plus 1 plus c for x in q, okay. X can be any rational meaning negative, okay, x in q, and of course it cannot be equal to -1. That's what we've just been studying lately, logarithmic function, okay. Okay, all right, so look, this is what you have here, right? What do you have? You have 1/2, 1 over 1/2. Well, you're multiplying two reciprocal, it's going to be 1 u to the 1/2 plus c, so it is u to the 1/2 plus c, okay. Anyway, you should be able to do it directly. All right, that's for the first problem. Second one, okay, let's look at this one. So you're given two function here, right? You're given the function g, that's on the famous color right here, and you're given the function f. Moreover, you're given an output of the function g. Now the function g is given with an integral, so I'm thinking fundamental theorem of calculus second part. When I see this, we'll see how that works, okay. And also f is defined in function of g, okay. What's the question? The question is find the equation of the tangent line to y equals f of x at x equals 0. All right, so what's the equation of a tangent line? First off, equation of the tangent line, tangent of f, of the graph of f, okay, at x equals 0. It's y minus f of 0 equals, that's the output at 0, f prime at 0, that's the slope, times x minus 0, okay. And that's a slope intercept, sorry, that's a point slope form, right? So it is y minus f of 0 equals f prime of 0 times x. Okay, so I need f of 0 and I need f prime of 0. Okay, well, f of 0. All right, so f of 0 equals, well, let's check out the expression for f of x. Where's f of x? F of x is right here. F of x is right here. So f of 0 is 3 times 0 squared, so it is 3 times 0 squared minus 5 times 0 plus g of 0. Okay, so that's just g of 0. Okay, now where's g of 0? G of x is right here. It would be complicated to compute this at 0 right here. If this is 0, I'm not sure how to compute that, but I'm giving you g of 0, right? Okay, so f of 0 is g of 0, which is pi over 4. All right, so this is done. We get this part. Let's get f prime of 0. So what is f prime of 0? Well, to get f prime of 0, you need to get f prime of x, okay? Don't derive pi over 4. That makes no sense. You need, that's pi over 4 is just the output, okay? So what is f prime of x? All right, so f prime of x equals, well, what is f of x? Here we go again. 3x squared minus 5x plus t of x. So it is 6x x minus 5x minus 5 plus g prime of x. Okay, alright, so what's g prime of x? Let me get g of x. G of x is what? Sum from -1 to x squared of 1 minus t square root of 1 minus t squared dt. Okay,